So what's the power of an exponent? In 1985, Cray2 was introduced with 1.9 gigaflops computing power, and it was the fastest supercomputer on the planet. And it remained a fastest machine on the planet for next 5 years. Today, all of us have a basic smartphone which has more than 10 times the power of Cray2. And we have that at a fraction of cost. That's the power of exponent. Good morning, everyone. I'm Dharmesh, Jani, and I'm here to talk about open domain-specific architecture, which aspires to continue pushing the performance gains, which we have so well enjoyed in the last many decades. And I'm also going to talk about how this ODSA project fits into the greater scheme of Open Compute project. Open Compute project was launched with 3 fundamental observations that for improving much needed data center efficiencies, we had to go through faster cycles of innovation, which is only possible through industry-wide collaboration. Launched in 2011, the first set of designs were those of data centers, which were far more power usage efficient than the existing ones. Over a period of time, more designs were added on the storage side, networking side, and the list of contributions, which today, as summarized in keynote yesterday, more than 189 contributions have happened from over 60 companies. This just gives a snapshot of contributions done by Facebook. The interesting thing about this set of contributions is that as you look at the sequence, it started with data centers, went through contribution of systems, subsystems, and in last 1 year, an exciting development of modules have been contributed into Open Compute, starting with OCP accelerator module. So this gives you some perspective of how OCP is evolving over the last 8 years, and where are we going next? That's an interesting question which we have in front of OCP. So that brings us to ODSA and the chiplet approach, which industry is already using today. If you classify the portfolio of solutions which are available using the chiplet approach, you can look at it on 2 dimensions. One, that of architectures, which are either open or closed, or solutions which are optimized for cost and power, which can be targeted or wide. And there are examples in the industry such as Intel's Kaby Lake G, which has CPU-GPU combination targeted for graphics application, or AMD's very famous EPYC line of processors, EPYC 1 and this year EPYC 2, which is combination of CPU cores and memory IOs. The interesting thing is these solutions are fairly targeted from cost optimized perspective. In contrast, open domain specific architecture wishes to be, of course, open, but it's also targeting wide range of applications. And we will see through the course of next few slides which are these applications which we are looking at. But this gives you a perspective of how ODSA fits in terms of looking at chiplet approach in the industry and comparing it with what is already existing. So this comes back to the question of what are we looking at next on Open Compute project. We talked about going from data centers all the way to modules. So the next logical step is obviously sub-module components. What goes into these modules? And this is where ODSA can provide a path forward by providing wide range of solutions which can be contributed into the module solution, which can be built up into subsystems, which can go into systems, which can then power the data centers which we need for all different kind of applications. So that gives you a perspective of how ODSA can fit in with the growing evolution of OCP. And now we are going to look at why exactly are we looking at ODSA chiplet approach? Why is it industry so enamored with moving forward with this? So let's start way back in late 1960s when Gordon Moore made now famous observation that number of transistors in a given die area was doubling every 18 months. And then over a period of next many years, that got refined from 18 to 24 months. And that lasted for 50 years. Even if you assume 24 months, that's 25 orders of magnitude growth. That's a phenomenal growth. And the interesting thing is during early part of decade of this growth, the performance matched the growth of the number of transistors in a given die. And that's the reason why we enjoy such a massive computing power in our pockets. However, exponents are very difficult to maintain. And the performance gains, which were so easily available and following the trend of transistor doubling, we lost those gains roughly a decade back. 2006, 2008, Dennards scaling plateaued, and the CPU frequencies have plateaued to roughly between 6 to 8 gigahertz. And there is no further growth which we have seen in the last 10 years. So this fundamentally requires new way of thinking. But the interesting thing is, Gordon Moore, visionary as he was, he never anticipated that his observation would last for 50 years. So he already anticipated that something would come after that. And what that would be building of large systems through collection of smaller, individually packaged functions which are interconnected. It's amazing. He made this observation pretty much at the same time when he made observation about Moore's law. It's just that the difference in time is 50 years. And now we have to go back to what he already envisioned would be the next step. And that's where actually you have to give kudos to the brilliance and creativity of the industry, that they maintained the push of Moore's law through transistor logic, gate logic, RTL, IP core. And now we are at the doorsteps of chiplet revolution, which aspires to continue that push forward. Why are we looking at this push forward? Everything has to have a reason. You don't do technology for sake of technology. And this is where it's interesting to look at natural systems. I love looking at natural evolution as an inspiration for a lot of things which we see in technology, because I feel that a lot of things which we are discovering in our lives, nature has already discovered millions and billions of years back. So if you look at something called Cambrian explosion of life, this happened roughly around 550 million years ago, where almost all of the modern animal phyla were created within span of 10 million years. The biodiversity exploded during that time, primarily because the richness of the environment and ability of life to be creative. We are seeing somewhat similar explosion from going general compute to specialized compute. Why? Because similar richness of data sets, needs of users, interconnectivity of users through ubiquitous Wi-Fi and internet, all of this is fueling need for completely new use cases which are driven by AI, machine learning, and data-heavy workloads. This is a push which we need to address through domain-specific architectures. Domain-specific architectures essentially are looking at two ways of addressing this. One is through logic disaggregation, where you take a big monolithic die and you split it into multiple dies, and you get cost gains. The second approach is through I/O disaggregation, where you look at different functions in different technology nodes and optimize their performance based on what is right sizing. And both of these approaches combined together today already exist as viable business cases. A very famous example given at IEDM by Dr. Lisa Su introduced the first generation of EPIC-1 processors. This year, AMD launched the second generation of EPIC processors, where you have 8 CPU cores, all designed and created in 7 nanometer, combined with a memory I/O, which is at 12 nanometer. And these are viable solutions which are basically used by companies to make money, which means there are viable business models existing which benefit from this technology approach. So that gives you some appreciation of where open domain-specific architectures lie, why we need them, how they fit into OCP. And as Bapi said, we can call it ODSA, we can call it ODSA, but this is something which is going to continue to grow in coming future, where people will use different approaches. Some might be proprietary, some might be open, but all of these would be used for addressing the diversity of workloads. I call this, in contrast to the carbon diversity, which we saw in the Cambrian explosion, I call it silicon diversity. Interestingly, same periodic table. So that comes to, what is the scope and the goal of open domain-specific architecture project, which is under OCP. We want to create standardized interfaces among these chiplets, primarily so that end users and solution providers can intermix these chiplets very quickly using some set of reference architectures which are developed through ODSA, have proof of concepts and prototypes and specific applications, not just for AI training inference, but even for storage, networking, for video and image processing, diverse applications, and then have a business flow attached to it, all of that creating a chiplet marketplace. That would be the vision which we want to aspire towards. And the interesting thing is, all of these approaches provide solution stacks and chiplets into the marketplace, and the marketplace in turn informs the group back. So the information flows both ways, because you provide a solution, somebody comes back with the feedback, you go iterate on your business flow, or you go iterate on your reference architecture, or you come up with new solutions. And at the end of the day, as we saw earlier, all of these sub-module components find their way into systems through modules, whether it's OCP NIC 3.0 or OAM, OCP accelerator module, or even other standard industry modules such as M.2 or dual M.2. So the idea is all of these things will work together to bring solutions which then eventually will power the data center. So where were we roughly 1 year back, and how have we grown? This initiative started somewhere around October of 2018 with 7 companies coming together. And today, it has grown to over 82 companies in less than a year. We are just tad shy of 1 year. That's a 10x growth. We are doing better than Moore's Law as of right now. So although the data set is only year of 1. If there is attendance to be proxy for number of people interested in this, that has continued to grow. And most of you have attended some of these workshops or all of these workshops, so I don't need to elaborate on that. But this is for people who might watch this video later on. There is continued momentum building across the globe in taking interest in this particular initiative. Just recently, in the last 6 months, this project became part of a server sub-project. So it found a home within OCP with the goal of nurturing the project to its logical growth, where the vision again is to grow it into a full project over a period of time. We also looked at the market opportunity, because at the end of the day, like I said, this is not about just developing technology. And IHS Markit did a recent survey. There are basically 4 basic use cases which are described: SoC, processors, GPUs, and PLDs. And these are across 6 verticals: wireline, wireless, consumer, computing, industrial, and automotive. So it's a pretty interesting space where you have multiple approaches and multiple verticals. Near term, we are looking at opportunity of roughly $500 million for SoCs. But the interesting thing is, we are looking at this in a long term. Remember, Moore's law lasted for 50 years and the gains happened over many decades. If you extend this, the open interface and the chiplet approach has a massive opportunity to continue to provide us these performance gains. We are looking at a really big numbers here. And this should motivate all of us to solve this problem collectively. Because the use cases are there, the demands is going to be there, and either proprietary or closed or open, solutions will deliver products which people will use and companies will monetize and build business value on top of it. So this is going to happen. It's just a question of who is going to benefit from all of this. And we believe very strongly that ODSA is well positioned, perfectly timed to take advantage of this. I won't go into detail. I think Bapi mentioned that he was trying to recruit 3 of you. Looks like he's already recruited 2. So this slide is only for that one person in the audience who we need to convert. But the idea is please come and join us. We have 3 work streams, and this is actually going to grow into a 4th one. We have heard loud and clear that software is a very critical element of ODSA. In the last workshop at IBM, there was vigorous discussion and the need for having monitoring, testing, integration, validation, and providing software stack. All of that is clear, so that would be something which we would be adding to this in near future. And then there are already 20 companies who are actively involved, and this number is surely to grow in coming months. There are multiple project areas where we need help. Our aspiration and the first step would be to take the BOE interface and make it into an OCP specification. So this would be another logical way to basically have ODSA join into OCP and then have a specification which becomes open and available for everyone in the industry to use. So with that, I just want to leave with one thought. And again, coming back to the initial observation that it took, the initial growth in semiconductor industry was a long journey of 50 years, which was done with the help of entire industry. No one company can claim to have pushed that envelope. For every long journey, it is best taken with group of people. We are on another long journey with this particular approach, and the best way to do it is in building a robust, healthy, open community, and that's why we are here today, encouraging everyone to join in on this journey. Thank you very much.
I have a question, though.
Yeah.
In your presentations, have you considered adding supply chain security for this ODSA block?
Excellent question. So actually, security is being discussed in multiple, this question is coming up in multiple panel discussions, and it is ranging from supply chain security to basically ensuring security at a higher level of stack as well. We don't have clear answer to how we will address it. Having said that, the interesting thing is the supply chain security is already being addressed in OCP by multiple companies. Microsoft has an initiative called Project Cerebras, and Google has another project called Open Titan. Both of these are explicitly for supply chain security. So the thought process which we have right now is that there's no need to reinvent the wheel. We are not security experts. The best way to solve this problem is to engage and involve security folks through OCP. So the idea is perhaps we need to take our requirements to the security group and develop a holistic security solution under OCP, which is already underway, and then have that cover the ODSA approach as well. So is there any specific thought which triggered that question in your mind?
Yeah. The thing is, I'm from Lattice. We are working with servers on bringing the whole system up as a part of PFR implementation, platform from where it means implementation. I can see a similar approach here. It's like when you bring the whole the ODSA platform up, you would need some security and a coordinated power sequencing and things like that within the platform. This is where Lattice can actually participate.
Your work group for you. Yes.
No, this is exactly the kind of input we need from folks like you. So, when is the next workshop?
Aiming for December.
Okay. Perhaps you can join us in that workshop and have a discussion on something around what Lattice approach is towards such.
Sure.
That would be awesome.
Yeah, as long as it's the first week of December afterwards.
Yeah.
My wonderful coincidence is likely is the big first week.
Yeah.
Okay, beautiful. Yeah.
Thank you, Shyam, for your question.
Okay.
Yeah. Any other question?